Okay, to begin, the information provided here plays no role in solving this question. It's merely meant to complicate things. Now here's what you do need to know. Angle Y is an inscribed angle containing the chord AB, and angle X is also an inscribed angle containing the same chord AB. Since both inscribed angles contain the same chord, those two angles must be equal. This is a property you must know for the GRE. Since both angles are equal, we know that X must equal Y, in which case our answer is C. To begin, let's let the legs of our triangle have lengths X and Y. Now, since our hypotenuse has length 12, we know from the Pythagorean theorem that x squared plus y squared must equal 12 squared. Also, since the area of this triangle is 28, we know that x times y over 2 must equal 28. Now, if we take this equation and multiply both sides by 2, we get the following equation. If we multiply both sides again by 2, we get 2xy equals 112. Now let's evaluate the following expression. You'll see why I chose this expression shortly. Now x squared plus y squared we know equals 12 squared, and 2xy we know equals 112. Now let's rearrange the terms on the left-hand side to get the following. This should look familiar now. The right-hand side we can evaluate to be 256. Now the left-hand side should look familiar because we can factor this to be x plus y times x plus y, which we can rewrite as x plus y squared. Now let's take the square root of both sides of our equation. When we do this, we get x plus y equals 16. And this is the piece of information we need, because to find the perimeter, we need to add x plus y plus 12. We now know that x plus y equals 16, so our perimeter is 28, and our answer is C. Alright, to begin, we are told that the circle has radius r. So if we add a center here, we know that this length must be r, and this length must be r. From here we can see that side AB must have length 2r. Using the same type of logic, we can determine that side BC has length 2r as well. Now the goal here is to find the length of diagonal AC. For the time being, we'll say that this diagonal has length D. At this point, I want to focus on this right triangle. Since we have a right triangle here, we can apply the Pythagorean theorem to get the following equation. From here, we can solve for D to get D equals 2 root 2r. So column A is equal to 2 root 2r. We're now comparing this with column B, 5r over 2. For our first step here, we'll multiply both sides by 2, and now we'll divide both sides by r, and finally we'll divide both sides by 4. Now we can take 5/4 and rewrite it as the decimal 1.25. Now since root 2 is equal to approximately 1.4, we can see that column A must be greater than column B, in which case our answer is A.
What is the value of W in terms of X and Y? First thing I'm going to say is look at the whole triangle, from A to C to E. Of course, the three angles in this triangle, or in any triangle, have to add up to 180. So I'm just going to call this angle here K. Then it's clear that X plus Y plus K equals 180. We could also say that K equals 180 minus X minus Y. Okay. Now notice, if we look at angle F, we have three little angles here, and of course they make a straight line, so they also have to add up to 180. And again we have X and Y, so this angle here must be K as well. So that means in this little triangle, DFE, we have all three angles now. We have W and we have two Ks, and so we know that W plus K has to equal 180, or W equals 180 minus 2K. Well, now we can sub in the expression we have here. W equals 180 minus 2 times 180 minus x minus y. And what we get is, we distribute that negative 2, we get 180 minus 360 plus 2x plus 2y. Rearrange a little bit, we get 2x plus 2y. 180 minus 360 is negative 180. And this looks a lot like answer choice A, the official answer.
To begin, we should recognize that the only restriction here is that this angle must be 100 degrees. This means we can change the shape of our triangle as long as we do not disturb this angle. So, for example, we could move this side out as follows. Here we see that the length of AB plus AD will be greater than the length of DC plus BC. So in this case, column A is greater than column B. Similarly, we could move this side out, in which case the length of DC plus BC would be greater than the length of AB plus AD. So here column B is greater than column A. So as you can see, our answer then must be D. To begin, we are told that the outer square has area 4x squared. This means that the sides of our square must have length 2x. Now if this side has length 2x, then the circle inside our square must have diameter 2x. If the diameter is 2x, then the radius must be x. Let's draw two more radii here. Now I've drawn these radii in very important locations. I've drawn them to coincide with the vertices of our square. Let's focus on this triangle. We can conclude that this triangle is a right triangle. So if we let our third side have length k, then the Pythagorean theorem tells us that x squared plus x squared equals k squared, which we can simplify as follows. Now what are we trying to do here? We're trying to find the area of the inner square. Well, the sides of this inner square all have length k. So the area of this square will be k squared. But we just calculated this to be equal to 2x squared. So as you can see, our answer must be D.
This one looks like a hard one, but it has a very elegant solution. First of all, let's just state the Pythagorean theorem in the triangle. We get 36, which is 6 squared, plus x squared equals r squared. And for reasons that might not be apparent, I'm just going to write this as 36 equals r squared minus x squared. Well, this equation, I'm going to write this as 5r minus 5x equals 9, or r minus x equals 9/5. Well, notice that r squared minus x squared, this is a difference of two squares, which can be factored into r plus x times r minus x. Well, r squared minus x squared, that's 36, equals r plus x times 9/5. So multiply each side by the reciprocal, 5/9. R plus x equals 36 times 5/9. Cancel the 9s, 4 times 5, r plus x equals 20. And that is the answer.
So in this geometry QC problem, we've got a triangle. The angle B of this triangle measures 90 degrees. So let's draw a right triangle right here, with a little dip, I guess, in it. And angle B is 90 degrees. The length of side BC is 3. And the length of side AB is x. And the length of hypotenuse AC is between 4 and 6 inclusive. So that could include the numbers 4 and 6 as well. And we're trying to figure out the relationship between x and 4 right here. So since it's a right triangle, we can use the Pythagorean theorem here. And what I'm going to do is just write 3 squared plus x squared. Now for the hypotenuse, I'm going to put 4 squared first. Because if we calculate the value of x and it turns out to be greater than 4, well, we've got our answer, since there's can only be one relationship between 4 is the least possible value for the hypotenuse. So let's do 9 plus x squared equals 16. Take the square root minus 7 from both sides. X squared equals 7. X equals the square root of 7. Now since the square root of 9 equals 3, the square root of 7 must be less than 3. So we know that in some instances, x is going to be less than 4. But what about others? Now, you may be tempted to pick like the number 6, and you could definitely do that. But also let's think about the part if what x equaled 4, because that would prove another relationship. So if x equals 4, let's get our quick triangle again. We have a 3, we have a 4, and that's a Pythagorean triple. That's a 3, 4, 5. And 5 is between 4 and 6. That's another relationship. So x could equal 4 as well. Since we've proven two different relationships, we don't need to go any further. We can confidently say that the correct answer is D.